All right, example 4, 12 minus 2x plus 5 equals negative 2 plus x minus 3. Here's a situation where the book does sometimes. It will put parentheses where they're not even needed, as in the case of this. And they usually, if they do something like that, they'll also do something like this, where they put parentheses where they are needed, but it looks about the same. So let's look at the difference between the yellow and the blue highlighted areas here. What's in front of the blue highlighted area?
A positive.
Plus, and in front of the yellow?
Negative.
A negative, okay? So, officially, if there's no number there, there's officially a 1 there. So officially, if I was putting numbers in here, there would be a 1 there, there would be a 1 here. All right? And if I were to multiply that 1 through, let's take a look at this right-hand side first, because it's easier. Negative 2 is just negative 2, nothing happened to it. If I distribute a positive 1 through the parentheses, I'm going to get positive 1x and then minus 3. So notice, plus parentheses x minus 3 becomes plus x minus 3. Absolutely no difference whatsoever. They're exactly the same thing. That's a situation where parentheses are not necessary, so I want you to be able to recognize that. So instead of doing a distributive property, you can just say, I don't need those parentheses, just throw them out. Parentheses on, parentheses off, exactly the same expression. On the left-hand side, 12 is 12. Nothing happened to it. Minus 1 times 2x makes minus 2x. Minus 1 times plus 5 makes minus 5. Notice that minus sign attached to both of these things. So 2x became negative 2x, 5 became negative 5. That minus in front of the parentheses actually made the parentheses necessary. Okay, but again, they look similar, but again, depending on what's in front, this had to be simplified. This one, just all we had to do was drop the parentheses off of it. Moving on to step 2. I got my left-hand side here equals my right-hand side here. Looking for like terms on the left-hand side, 12 and negative 5 make positive 7. Minus 2x, there is no like terms with the x. This is positive, this is negative, so I subtract. 12 is bigger, so it's positive. On this side, 2 and 3 are like terms, right? Minus 2 and minus 3 have the same sign, so I add them together. 3 is bigger, so it's negative. Plus x has no like terms. I might recommend for you guys at this point to put numbers in front of x's that don't have numbers there, just to remind you there is one. Again, that's looking at past performance of Algebra 1 students. Forgetting to put a 1 in front of that x, or forgetting there is a 1 in front of that x, causes some people to mess up. So you go ahead and put a 1 in front of the x. It doesn't hurt anything, and it might help you to get the right answer more often. All right, based on my theory of which one I should move, which one do you think I should move for x?
Negative 2.
Negative 2, right. My choices are negative 2x and positive 1x. 1 is bigger than negative 2. I always move the smaller x term. And if I move the x to the right-hand side, numbers go to the left-hand side, so negative 5 has to move over here. What you should look at every time, if you put a bar right there where the equal sign is, everything containing x is on one side, everything containing numbers on the other side. If you did it that way, you did it right. And again, anything that moved changed signs. Negative 2x became positive, negative 5 became positive. 7 stayed where it was, 1x stayed where it was. They stayed the same sign. Combined like terms, 7 plus 5 is 12. 1x plus 2x makes 3x. The coefficient of x is 3, so we don't always divide by the coefficient of the variable. In this case, 12 divided by 3 is equal to 4. If your improper fraction reduces to a whole number or integer, please write it as such. Don't put 4 over 1. It's not wrong, but it's just unnecessary and it's a bad habit. So 12 divided by 3 equals 4. The number 4, not 4 over 1. Much better way of writing it there.